Section 8.3 is titled Slope. Today we're going to discuss defining slope as a vertical change for every unit of a horizontal change. Recognizing that if it's constant, it will indicate a linear function, which is what this whole unit is about. And then we'll also identify and describe some situations with constant or verifying rates of change. So first is just a definition. Slope is a ratio, so it's a fraction, of the rise, which is the vertical change, to the run, which is the horizontal change. Another way to think of slope is that it describes the steepness of a line. So the steeper that a line is, the bigger its slope will be. And by bigger, I just mean it's a number, it has a value. And on a line, slope is always constant. So no matter where you are on that line, the slope is the same. What we want to focus on, though, is that slope is rise over run. So slope can be positive or negative. So please draw just a quick graph in your notes. It doesn't have to have labels on it for the axes. The red line is negative, the green line is positive. So if you want to highlight or maybe dot one of them in, make one with dashes and one a solid line, just so that you know the difference. And then write these important bullet points off to the side. So positive slopes represent a rate of increase. So that means that as you move along this line from left to right, we are increasing. We're going up, up, up. Negative slopes represent a rate of decrease. So things are going downhill as you move from left to right. So again, steeper slopes represent a greater rate of change, while less steep slopes represent a lesser rate of change. When you hear the term rate of change, that means slope. Slope can also be zero, indicated by the perfectly horizontal blue line, or undefined, represented by the orange perfectly vertical line. It's important here to know that a zero slope line has no rate of change. So let's look at some examples where we have the function graphed. The linear function is graphed, and we want to figure out what is the slope. So this is literally a counting process. So remember again that slope is the rise over the run. And because it's a straight line, the slope is the same anywhere on that line. It doesn't matter what ordered pair you start with. You do always want to make sure that in order to start, or that to start counting the slope or to figure out what the slope is, you do want to start on an ordered pair that you know. So you can see them all kind of dotted in here. There are 5 of them. So I'm just going to start here, this second ordered pair at -4, -3. And I'm going to count from this ordered pair to the ordered pair at the origin. So again, it's the rise, so I need to count up, and then I'm going to count over the run. So when I count up, you start at the ordered pair, but you don't count that. That's not 1, that's your starting place. So I go up 1, up 2, up 3. And from here, again, don't count where you start when you move to the right, going over 1, over 2, 3, and 4 before I land on the ordered pair. So the slope is 3 over 4. Now you could have gotten that from anywhere. I could have started up here in the upper right hand corner, up 1, 2, 3, over 1, 2, 3, 4. You still get 3, up 3, over 4, up 3, over 4. The important part to remember about slope is that it's always the y value, the up and down, the vertical change on top. You also could go from one point further down on the line and skip and try to get to another one. So let's focus on the bottom ordered pair, and I'm going to go all the way to the second one. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's up 9 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 9 over 12. We'll recognize that 9/12 reduces to 3/4. So on a straight line, it doesn't matter where you try to count for the slope. As long as it's reduced, you should always get the same answer. Let's look at another example. Hopefully here you're recognizing right away that this slope is negative because it's going in the negative direction. And that's just something you have to know. So here, slope, it's still rise over run, but this time our answer is going to be negative. And I still just do the counting like normal, and then I just remember to put the negative sign on my answer. So I'm going to start here on this point, and I'm going to go to the left. You can go to the right, you can count down and over, or you can count up and over. It's your choice. So up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6, 4/6. You always need to reduce your slope, but it does need to stay in a fraction, so negative 2/3. That's the rate at which this line is changing. So for every 2 units you move down, you go over 3. 2 down, over 3. 2 down, over 3. 2 down, over 3. And I'm saying down because it's negative. Example 3, we have another negative sloped line. So I know that my answer is going to be negative. And I can start way over here on the left and count down and over. Just remember it's the vertical counting that goes on top. So down 1, 2, 3, 4, down 4, over 1, 2. So that's negative 2 over 1, or just negative 2. You'll notice the slope of this line, that's negative 2, compared to the slope of the previous line, which is negative 2/3, you can see how steepness, this line is much steeper. So the absolute value of negative 2 is 2. It's a much larger steep. It's a much larger slope, excuse me. There's also what we call a slope formula. So now if I give you 2 points that are on a line, you can calculate the slope. Sure, you could graph both of those ordered pairs and then do the counting like we just did, or you can use the formula. Slope formula is red, m, and m is the variable that we use to represent slope. M equals y2 minus y1 over x2 minus x1. We'll be working with this formula a lot over the next few days, over this whole unit. But all you really need to focus on here is that there are 2 ordered pairs, x1, y1, and x2, y2. The 1s and the 2s that are the subscripts, the only thing those mean is that there are 2 ordered pairs. It's distinguishing between the 2 different x's and the 2 different y's. If there was a 3rd ordered pair, we would call that one x3, y3. So what you do on this, you take the 2nd ordered pair's y and subtract the 1st ordered pair's y from it on top. Remember, y's go on top with slope. Then on the bottom, we do x2 minus x1. So let's do some examples. I'm telling you the line passes through these 2 ordered pairs. I want to know the slope. I'm going to put the formula up here. y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. I always come in and label right away. So we do negative 1, because that's y2, minus 3, over x2, which is 4, minus x1, which is negative 2. The only thing you have to be careful with is when you're subtracting a negative. So we add the opposite on the bottom. So that's negative 4 on top over 6. Divide the top and the bottom by 2, and we get negative 2/3. So if you had those two ordered pairs plotted on a graph, and you drew a straight line connecting them, if we counted the rise over the run like we've done in our previous examples, you would get negative 2/3. That means our line should go in this direction since it has negative slope. Next example, we have negative 4/3 and 1/2. So again, slope equals y2 minus y1 over x2 minus x1. So if we label our ordered pairs, x1, y1, and x2, y2, that gives us 2 minus 3 over 1 minus negative 4. Again, the formula has subtraction signs in it, so when one of the numbers is negative, you're subtracting a negative, so that's the same as adding a positive. 2 minus 3 is negative 1. 1 plus 4 is 5, so our answer is negative 1/5. Again, the slope for this line would go in this direction, the negative direction for slope. I think this might be the last example, so if you want to pause the video here, try to plug the numbers into the formula on your own, and then check your answer. So we have x1, y1, and x2, y2. So the slope is going to be 3 minus 5 over 8 minus 1. y2, y1, x2, x1. I always try to remind students, start with the ordered pair that's in the back. Start with the second ordered pair, put those numbers in first, y on top, x on bottom, then subtract the y and the x from the first ordered pair. So that's negative 2/7. That doesn't reduce, so the slope is negative 2/7. And we will work on worksheet 8.3.